Hey folks, welcome to my channel Number Pen. So we have the problem on our screen. Examine the continuity of the function x plus sine x, right? So in this video and in the videos that are going to follow today, we're going to look at problems using the algebra of continuous functions, right? And I have put them up on the right of this particular screen. And so let's assume we have two functions, right? F of x and g of x. And if f and g are continuous at x naught, then the following rules apply, right? And these rules are based on simple algebra of functions, right? So if f is continuous at x equal to x naught and g is continuous at x equal to x naught, then the function f plus g is also continuous at x equal to x naught. And similarly, we have f minus g also continuous at x equal to x naught, right? And then we have f into g also continuous at x equal to x naught, and f by g is continuous at x equal to x naught. And you'll have to remember one important thing here: the function is not continuous at those points where g of x equals 0, right? So g of x should not be equal to 0. And why is that? Because when g goes to the denominator, the entire function, when it is equal to 0 and the denominator, you get an infinite, which becomes uh, you know uh, which violates the first principle of continuity we saw in our first video on continuity. And then so you'll have to remember one another important thing as we discuss the algebra of composite functions, right? Now let's assume out of f and g is not continuous at a particular point, right? And f is continuous at all points, right? Say belonging to the set of real numbers belonging to R. Then f plus g is discontinuous still at that point where one of these functions, be it an f or a g, becomes discontinuous, right? So that's the other way of looking at algebra of these complex function of these continuous functions. And it is on that basis we're going to try solving some of the problems in this video, right? And lastly, I have the fifth rule written here, which is a composite function theorem on continuity. If f is continuous at g of x naught and g is continuous at x naught, then f dot g, which is a composite operation, which is nothing but f of g of x, is continuous at x naught, right? And I'm not going to go into the details of this particular composite function theorem until we come across a problem that uses this particular rule and examines the continuity of a function, right? So with this, let's move on and solve the first problem in this video, which is x plus sine x, right? Now if I treat my x as f of x, right, and my sine of x as g of x, right, and let's probably write that down in so if I'm going to treat my f of x equals x and my g of x equals sine x, then I know that f of x is continuous. Let me highlight that. And I know that g of x is also continuous, right? But in both these cases, they are continuous in the domain f x belonging to R, right? So which means my f plus g, which is nothing but my x plus sine x, right? Since f of x and g of x are continuous for every point x belonging to R, we can comfortably conclude that x plus sine x, and if I call this function as, say, let's call it h of x, right? right? And h of x equals f plus g is also continuous for all points, for every point x belonging to R, right? So that's how we go about solving these problems. And before concluding this video, I would like you to remember a few basic continuous functions that will come in very handy when you're going to solve these type of problems, right? For example, x is a continuous function, and that's obvious, right? It's a continuous function in the domain of R, which is the open interval minus infinity to plus infinity, right? And similarly, sine x is again a continuous function. Cos x is a continuous function. X square, which is a square function of x, is also a continuous function, right? So likewise, uh, you know, these are some of the basic continuous functions that uh, you will have to remember uh, before applying the algebra of continuous functions to solve these problems, right? And I don't want you to necessarily memorize them. As long as you know why these functions are continuous, it's fine, right? You'll be able to crack these problems in a very easy way. So I hope you found this video useful, and please do subscribe to my channel and support. Thank you.